Very welcome to everybody who is watching our project. The name of our project is Automatic Street Light Using LDR. And the members of our project is Aaron, Ashwin, Glenn, Lydia, Nia and Shine. We are the students of class 12A. So in the project, me, Lydia John, is doing the introduction. So as I have told you, the name of our project is Automatic Street Light Using LDR. Let's look what is the aim of our project. Okay, before I tell you the aim, let me show you the working model of our project. Since it is an automatic street light, I'll show you. Okay, so this is the working model of our project. Here there is a multiple street lights attached, but in our project we are only using a single light in the project. Okay, so the aim is to work out the automatic street light by using a device called LDR. So you might probably be thinking what an LDR is. So let me introduce you what an LDR is. Introducing LDR. What is the full form of LDR? Yes, light dependent resistor. LDR is a device whose sensitivity depends on the intensity of light falling on it. Okay, when the light of falling is increased, the resistance decreases. The intensity of light is decreased when the resistance increases. In short, we can say that resistance is inversely proportional to the light intensity. So can you see you can see the diagram of LDR, that is light dependent resistor, and both the symbols that you can see on this picture can be used to symbolize LDR in your circuit. Okay, the next device that you will be coming across in this whole project, that is a transistor. Transistor is a device as shown here, and in our project we are using the same transistor which is shown, BC547. Okay, so let me tell you what are the parts of transistor. As you can see, there are three terminals in a transistor. One is an emitter, the middle is base, and the third is a collector. Transistors are of two types. In our full project, we are using an NPN transistor, and an NPN transistor is shown here in this picture. Okay, so this is an NPN transistor, and we will be learning more about LDR and transistor in the theory session. Okay, I hope the introduction part is clear to you all. So now let's see the project.
Apparatus: a LDR, light dependent resistor, a NPN transistor, two resistors, an LED, breadboard, 9-volt battery, and a wires for connection. A LDR. A LDR has two endpoints. The symbol used for LDR in the circuit diagram is this. The resistors. NPN transistor. There are three endpoints for a transistor: emitter, base, and collector. The materials required for the project is this.
Now, the theory of automatic street light using LDR. The working principle of LDR is that it gives less resistance in high light intensity and high resistance in low light intensity. That is, it gives high resistance in dark or night and low resistance in day or light. To save electricity and reduce manpower, we can simply convert normal street light into automatic by using automatic street light controller using LDR. We know LDR, that is light dependent resistor, has been used in many applications, and by proper employing in circuit, LDR can act as a perfect light sensing element. This automatic street light operates based on the atmosphere sunlight. When the sunset occurs, this circuit detects darkness and makes street light on. When the sun rises, this circuit detects and makes the street light off automatically. Next, transistor. What do you mean by a transistor? A transistor is an arrangement obtained by growing a thin layer of one type of semiconductor between two thick layers of similar type semiconductor. There are two types of transistor. In this figure you can see first one is PNP transistor, second one is NPN transistor. And this transistor consists of emitter, collector and base. Transistor is used in the cutoff for saturation state. It acts as a switch. On the other hand, it is also used as amplifier. Next topic is diodes. In electronics, a diode is a two-terminal electronic component. that conducts primarily in one direction. It has low resistance to the flow of current in one direction and high resistance in the other. A semiconductor diode, the most common type today, is a crystalline piece of semiconductor material with a PN junction connected to two electrical terminals. This unidirectional behavior is called rectification and it is used to convert alternating current to direct current. So, what is the purpose of rectification? To convert AC to DC. LDR, that is light dependent resistor, are very useful especially in light or dark sensor circuits. Normally the resistance of an LDR is very high, but when they are illuminated with light, resistance drops dramatically. Electronic sensors are devices that alter their electric characteristics in the presence of light. The best known devices of these types are the light dependent resistors, the photodiode and phototransistors. As the name suggests, depending on the light on the resistance value varies. Thank you. Next, we have Ashwin to present circuit diagram of automatic street light using LDR.
This is the circuit diagram of the automatic street light control system. We can see that the 9-volt battery and LED is connected to the circuit. And there are two resistors R1 and R2, each of 470 kilo ohms. BC547 is a NPN transistor. This acts as a switch on this circuit. As you can see on the screen, this is the image of LDR, light dependent resistor. And finally, this is how it works. When we block the light falling into the LDR, you can see that LED glows. When the light falls in LDR, the LED will be off.
Working principle of automatic street light using LDR. So now it's time to watch working principle of automatic street light. So in this whole project, we saw that there are two important components we are using. One is an LDR and other is a transistor, an NPN transistor. So we will be looking the working of an LDR separately and the working of a transistor separately, and then we will be uniting the two and we will be learning the working principle of an automatic street light. So working of an LDR. The working principle of LDR is that it gives us low resistance in high light intensity and high resistance in low light intensity. Low light intensity means darkness. So we know that light intensity is inversely proportional to resistance in the case of LDR. Now it's transistor, the working of transistor. In the project, that is automatic street light using LDR, we are using transistor as an on-off switch. Now let's look how does it work. Every transistor has a saturation voltage. A saturation voltage is a voltage that we can consider it as a borderline voltage. In a very simple term, we can say it as a borderline voltage. Now, if the current passing through the transistor is higher than this saturation voltage, then it is off. And if the current passing through the transistor is less than the saturation voltage, then it means that the transistor is switched on. So this is the working of a transistor as an on-off switch in the project. So this is a circuit diagram. Here we can see that there is an LDR at that side. We know it's a symbolic representation. So resistance, there are two resistors R1 and R2, 470k ohm. Then there is an NPN transistor of BC547 NPN. Then there is an LED, a battery of 9 volt. Working. During daytime, there is a presence of light, right? Yes. We can see that the intensity of light increases and so the resistance decreases in the LDR. When the resistance decreases, the voltage in the transistor increasing, resulting to be off during daylight. At night time, there is an absence of light, therefore we can say that there is a decreased light intensity, or we can say that there is no light, making the resistance of LDR to be high. Since there is an increase in resistance causing the voltage to be lower, causing it to switch on, making the LED to glow during the absence of light or a dim light. So this is actually the working. At daytime it is switched off and at night time it is switched on. So it is the working of the automatic street light using LDR. Okay.
features. Place the transistor on the breadboard. Connect the emitter to the negative of the battery. Base to one terminal of LDR. Connect the resistor R2 to base and positive terminal of battery. Collector to the anode of LED. Cathode of LED to resistor R1. Another end of resistor R1 to positive terminal of battery. Another terminal of LDR to negative terminal of battery.
Observation and graph. Observation first. Using LDR, we control the street light. When the LDR value falls above the threshold value, the lights are switched on, and when the value falls below the threshold value, the lights are switched off. In order to save and conserve energy in an efficient way, an intensity controller based on movement detection is used. Second, resistance changes with the amount of light that falls on it. Third, the light energy produces more free electrons, which increases the current for a certain voltage across LDR, which means a drop in resistance. Hence, very little current flows through it in dark. Fourth, LDR is used as light sensors. Graph. According to this graph, the LDR gives less resistance and high intensity, and high resistance in low intensity. It gives high resistance in dark or night and low resistance in day or light. Third, the x-axis shows the illumination and the y-axis shows the resistance at different intervals. Thank you.
To one and all, this is the conclusion of the project Automatic Street Light using LDR. This project of automatic street lights is a cost-effective, practical, eco-friendly and the safest way to save energy. It clearly tackles the two problems that the world is facing today, and a disposal of indecent lamps in a very effective manner and also saving of energy. According to statistical data, we can save more than 40% of electrical energy that is now consumed by the highways. Initial cost and maintenance can be the drawbacks of this project. With the advances in technology and good resource planning, this cannot be a problem, as the cost of the project can be cut down, and also with the use of good equipment, the maintenance can also be reduced in terms of periodic checks. The LEDs have a long life. They emit cool light, don't have any toxic materials, which makes them suitable for fast switching. For these reasons, our project presents far more advantages which can overshadow the present limitations with ease. Keeping in view the long-term benefits and the initial cost would never be a problem, as the investment time return is very less. The project has scope in various other applications like providing lighting in industries, campuses, parking lots of huge shopping malls, etc. This can also be used in surveillance in corporate campuses and industries. Thank you.
Precautions. Never work on a circuit while power is applied. Do not connect power to a circuit until the circuit is finished and you have carefully checked your box. If you smell anything burning, immediately disconnect the power and examine your circuit to find out what went wrong. Keep your work area dry.